Good morning, good evening. This is Dr. Tarek Tutunji from Philadelphia University, and today I'm going to present our work with cooperation with German Jordan University and Michigan Technological University. The work is called Interfacing Computing Platforms for Dynamic Control and Identification of Industrial KUKA Robots. This work was done by students mainly, Laith Suleiman, Statiye and Dirbasi. Their supervisor was Dr. Nadir Rawajde. So let's start the presentation. So let's have an overview. So this paper will present a user interface. We're going to call it the GJU, which is German Jordanian University KUKA Toolkit. It was developed as an interface platform between the KUKA robot and the KUKA industrial robot and personal computers. Two features were developed in this toolkit. The first one is the data logging. We used the JOpenShow-var toolkit. It's an open source kit. We use that to collect logging data, dynamic data from the position and the orientation of the robot and the 6 joints. Send this data from the KUKA to the personal computer. And then on the other feature is the drawing feature. And here we used an OpenCV library in order to upload the image, filter the image, and send those images to the KUKA for the drawing. So what is the main contribution? Well, the main contribution of this is that we developed an open source software for KUKA, and we uploaded this on the internet, and you can see the links for it. So it's an open source for KUKA robot, used for monitoring and programming. Okay, it can be used for educational purposes and it can be used for research purposes. And this is the KUKA robot that we used in German Jordan University. So the outline. First, we're going to give some ideas and general look at the GJU toolkit, what softwares we used, and how the interface, what kind of interface we used. And then we'll talk about the data logging feature, and then we'll talk about the drawing feature. So the toolkit uses the following. What do we use as software and the interface? We used 4 main elements, let's say. We used the JOpenVar, which is a Java-based open source package, and we use it for the communication interface between the personal computer and the KUKA. Now we need to use another interface as well, KUKA var proxy. This is an open source as well. This one is actually uploaded on the KRC KUKA, which is the KUKA robot control. So we have two open source for the communication. One is installed on the computer, one installed on the KUKA controller. And then for the drawing part, we use the Python-based OpenCV. This is an open source vision library that is used for processing images and extracting features of images. And then finally we use the NetBeans, which is the integrated development environment, the IDE that we use to put all the source code and all the libraries on. We used Java programming here. So let's take a look at the general interface and the structure of the communication between the computer and the KUKA. So what we have here we have 2 blocks. We have the computer block, and then you have the KRC, which is the KUKA robot control that is actually connected and controls the physical KUKA robot. So we installed the JOpenVar on the computer and installed the KUKA var proxy and the cross communication API. We have those installed, and KUKA var proxy and JOpenVar, they're all both open source, and what they do is they communicate through the TCP transmission control protocol. So when we send information from the computer to the KRC, the JOpenVar will encode this in a packet and send it to the KUKA proxy, and the KUKA proxy in turn will decode this information, send it to the KRC unit. At the same time, the KRC unit will get the information from the robot, goes to like the logging information from the robot. It goes to the KUKA var proxy. In this case, the KUKA var proxy will be the encoder, send it to job. JOpen var will decode and take it to the computer. And this is an example of the screenshot of one of the packages that is sent between the on the TCP. So here what you have is the point to point. So you have the XY, you have the XYZ, which are the positions, and you have the A, B, C, which are the orientation of the robot, of the end effector. So this information gets sent as a packet, and this is the packet that it sends on the TCP. So you have the red is the variable ID, so this variable ID 1, and then the total message length is given here 37. And then you say if you want to read or write, in this case 01, so you're actually writing. And then you have the variable length name, and then you have the right data length. It's right here, data length 002D, and then finally the data that you want to write. So this is the data that is being sent that you want to write, and it's going through the TCP. So this information was encoded as a packet, and this is the packet that was sent. So let's take a look at the first feature, which is the data logging flow diagram. And if you take a look at this, so once the program gets started right here, and then the process is initialized, once it's initialized successfully, it goes to the second stage, and then you can load the initial configuration that you want to use. And then you set the parameters, the variables that you want to monitor, you store the variables, and then once you press start, and then the connection is established, then it can start logging. So it goes to start logging services, it goes to the logging system, and it initializes the login, and it starts the timer, and then it loops over here, and it starts to log and starts to capture the logging data that's coming from the KUKA, and it goes and stays on the loop. And until it's done, until you press stop. Once you press, it's terminated. So this is the main flowchart that we used, and this was programmed in Java. And this is screenshots of the interface right here. So this is the user interface on the computer, and then right here you put the variable name that you want to monitor. And for example, this is the position, actual position, and it's got the information of the position and the orientation. And then you use this screen to choose the variable that you want, and you start the connection with you got the IP address on. And then after it's logging, then the file that you log, the information that you log from the KUKA is stored in the computer. So this is a screenshot, a small part of what was stored on the computer. So here's it's taking the actual position, and it's storing the sample time, and the values, the A, the B, and the C are the orientation, and then the X, Y, Z are the pose of the end effector, and the A1, A2, A3 are the variables, the angle of each axis. We will show you a demonstration of how the system works at the end of this presentation. So the second one is the drawing. So the second feature is the drawing flowchart. So once you system the start and the system is initialized, and then you go here and you capture an image, you get the image from your computer, you upload it, and then you do any parameters filtering you want with it. And you might do some feature extraction, you might do some filtering, and then you run a program to find the motion points right here. You run a program to find the motion points. So a simple program, this program actually calculates the required points to form the shortest path. It goes from point to point, and then it established, and then when you press the start command to start the process, it checks the connection, and if the connection actually is established, so the drawing service starts, and it instructs the manipulator to start. So you get the starting point, and instructs the manipulator of course, this information goes straight, goes through the JOpenVar to the proxy, KUKA proxy, and goes to the controller, and then the controller instructs the manipulator to move the position and to do the calculate to actually move the robot and do the point-to-point drawing. So you have the starting, you set the starting point here, and you set the parameters. And then you set my point-to-point frames, coordinates, and some delays, and then it keeps on looping in here according to the. So you already ran a program to calculate the shortest path, and this was taken to the KRC, and then now it's actually going through the drawing algorithm. This is an example of screenshots. Again, this is a screenshot of the interface for an OpenCV, and this is the OpenCV interface, and then you can upload any message, any figure, any file image that you want. It can be a JPEG file, for example, and then you have here some buttons that user interface that you can use so that you'll change the you can change the resolution on, or you can do some filtering. And this is the final drawing. So in this case, we are actually drawing a KUKA. So we have a KUKA drawing a KUKA. This is the drawing that was drawn, and this was the pen that was actually attached to the KUKA, the physical KUKA. So now what we're going to do is that we're going to show those interfaces. We're going to show the toolkit interface and the KUKA movement. And let's see what we have here. And we're going to open this, and then we'll start with the toolkit. OK, so let's start with this. So this right here is the interface for the JOpenVar, and this interface for it. This is the GGU KUKA toolkit, and those are the variables that we're using: the position, the actual position, and the axis variables. And then you can control the speed that you want to set, and then so we're okay. Then this is where you connect. You do the connection. This right now actually is connected, and it's connected to an IP address at a certain port. And then what you can do here is, for example, you can change some of the variables. Okay, so you can delete some variables, or you can add the variables that you want. And those variables are the ones that as defined in the KRC, the KUKA. And now what we're doing, we're going to log a file, and then we go to desktop, and then we, let's say we're going to select a new folder. We create a new folder called KUKA log. And then we select the variable that you want to monitor. For example, you want to monitor this variable, and those are the information that we gathered. So those are the information, got the sampling time and the value number that we used. And then we can take a look at another file. We can take a look at the actual position, and this was that was logged in. So if I stop this for a little bit, and you can see you have the A, the B, and the C. Those are the orientation angles, and you have the X, you have the Y, you have the Z. Those are the position of the effector, and you have the A1, A2, A3, A4. Those are the positions of the of each one of those axes. And so we'll log in the file and take a look at the file for depending how many samples you get, how long you run it, and for how long how short it is, what sampling period used. So let's take a look at another one here. We have another file that shows how the drawing works. So this is the KUKA drawing. And so this is the interface that we have for the OpenCV, and this is an image that we uploaded, and you can actually just go here to choose an image, and you can pick an image stored on your computer, and then you can control different filters here. And let's see how this one works as an image. So for example, I can change the resolution. So I'm changing the resolution here. I can do the contours. I'll take the contours of the image, and then I can change the resolution of this one as well. And then I connect it to the IP address where I want to send it to, which is in this case the KRC, and then you connect it. So now it's connecting. This is the total points that it needs to do, 600, 254 point-to-point drawings, and now it's connecting. And so it is connecting, doing the communication, and now we have the screen is split between the image that we want to draw and between what the KUKA is actually drawing. And you can see as the pen moves, as the KUKA moves around the contours, you can see here in the image it shows you exactly what what the KUKA is drawing, and you can compare both and see that it's doing a good job in drawing a 2D drawing of this picture. And then this is on fast mode. This is the we're drawing the KUKA. So now the KUKA is drawing an image of a KUKA. So it's got, of course, good accuracy. That depends on the KRC itself, but the communication between the personal computer and the KUKA is successful. So, in conclusion, so this paper presents interface toolkit that was developed at GJ. This toolkit established communication between the main thing, communication between KUKA robot and the personal computer for 2 operations, 2 features, data logging and drawing. And we used different toolkits and libraries. Mainly, we used the JOpen, Shovar, and the OpenCV. And this toolkit is being used for research and education purposes. Thank you for your interest.